now we get to hear from some of the companies that are actually growing the industry in New York City. And we have 10 of them, I think. Yeah, so there's quite a few, and they're all doing different things, which is really exciting. So Sabria is going to moderate for us.
You guys want to come on up? Hi, everyone. You may recognize me from being on a panel earlier this morning, but now I have turned into a moderator for the Growing the Industry in New York City panel. And so the way that this will work, as Nancy said, there are 10 companies that I would love to introduce you all to. We've split them up into 2 sections. This first section is going to be companies that are focused in the food tech and synthetic biology space. I will allow them a few minutes to tell you about themselves, their technologies, their companies, and then we will have hopefully a lively, moderated discussion. And Q&A from you all. So with that, I'm going to pass it off we'll have David start. Oh, you already have a mic.
No problem, Eric. I'm already set up. Thanks so much for having us today. My name's David Heller. I'm the co-founder and head of operations at C16 Biosciences. We're based over at the Hudson Research Center on the west side of Manhattan, West 54th Street, which we love dearly. We got started about 5 years ago, and our large mission when we first got started was to decarbonize the consumer goods space. We got focused by sort of discovering and understanding a major issue with a key ingredient in our supply chain today, which is palm oil. Palm oil is the most commonly used vegetable oil in the world. It's in 50% of consumer goods, but a lot of people go throughout their day without even realizing they're using it. It's an ingredient in your personal care products and your lotions and shampoos and lip balms, and also in food and a lot of packaged goods and frozen pizzas, chocolate snack foods, all sorts of things that we use every single day. The issue comes in the way that the industry is currently expanding. Most of palm production is produced in Malaysia and Indonesia currently. And the trees that palm oil is extracted from have to grow within 10 degrees of the equator. Most of that land today is tropical rainforest. And so what's been happening as this industry has been growing over the last few decades is tropical rainforests are literally slashed and burned away and replaced by oil palm plantations, which drives tons of CO2 emissions, kills and drives out large mammal species, drives out indigenous peoples who make use of the rainforest. It's a really sort of catastrophic industry expansion. And so we took a hard look at this industry and said, well, why is palm so big and so useful? And also, why is there no good agricultural alternative? And a lot of that comes down to 2 big things, which is the chemistry of the oil itself. It's very unique. You don't find that saturation and unsaturation levels in things like sunflower oil and canola oil, but also the economics and the actual, the specific economics of the oil itself. The crop that makes palm oil is the most productive oil crop. So if we look at governments and say, hey, you have to switch from palm oil to sunflower oil to try to prevent future expansion of plantations, you would need 3 or 4 times as much land to make the same amount of oil as you do with palm. And so we said, okay, agriculture is not providing a good alternative. We wanted to turn to microbiology. There's an incredible array of microbes out there that actually naturally convert sugars and other carbon sources into lipids, which they store as an energy source to be used later by the cell itself. And so our goal was to say, okay, can we focus on a cell type, a yeast that we found, that could produce an oil that mimics palm oil's profile in terms of the fatty acids that are present, in terms of the actual physical and chemical properties of the oil, so that we can create an oil using biomanufacturing in large stainless steel tanks, where we can expand vertically, instead of the current industry which has to expand sort of horizontally on large swaths of land. And so we began this process a couple years ago. And we've built an amazing core technology around what's called precision fermentation. And it's this concept of using microbes as your tiny factories, right? We use yeast that naturally, like I said, converts sugars into oils. We've developed a high-throughput screening process whereby we can sort of isolate highly optimized yeast cells, yeast strains, that can convert a specific feedstock type into a specific fatty acid profile, which for us mimics the vegetable oil that we're looking to target, which right now is palm oil, crude palm oil alternative. And so we built this core technology up a couple years ago. The first couple years of the company's existence was really focused on de-risking this technology and then getting to scale. And we hit a really amazing milestone the last couple months, getting to 50,000 liter commercial scale for the first time, and we're beginning to launch with personal care brands who are really excited about switching away. So with that, I'll hand it over to Anthony.
50,000 liters, that's good. Hi, I'm Anthony Clark, Chief Technology Officer at Helena. I joined Helena a year ago. We'll talk about Helena in a second, but as you can tell, I've been around a wee while, so probably 25 years in the synthetic biology space. Started off in the flavor and fragrance industry. I think earlier we were talking about glowing plants this morning. Well, we made plants that smelled really nice. So it wasn't exactly the goal. The idea was to make terpenes for the flavor and fragrance industry, and ended up making very nice smelling tobacco plants. So this industry has been going on for quite a while, and from the plant side, and then we moved into engineering microbes such as yeast, and ultimately that patchouli material is now made in yeast, and that was also with the company that we talked about earlier, Amaris, that was working with Firmenich to develop that process. So that was probably the first large-scale industrial fermentation of nice-smelling compounds, and is still going on today. And then working at Helena is focused on reintroducing nutrition into infant formula. So we're taking the breast milk genes from the mother, putting them into yeast, engineering the yeast, training them to make the right form of that protein, including its own glycosylation profile. And these proteins are very, very nutritional. We announced yesterday that the first protein we're making is called lactoferrin, which is a really important protein. It's immunoeducational, so it trains your immune system, which allows the increase in the biodiversity of your microbiome, which in turn leads to cognitive improvements and all kinds of nutritional benefits, not just in neonates, but also in all stages of life. And we're focused on ultimately moving forward into infant formula, but we will develop these ingredients for non-infant uses starting in 2024. So we just also scaled to 45,000 liters. So just came back from that campaign, and we're super excited to move this material into the market.
My name is Vishal. I'm the co-founder and CEO of Annika Biosciences. At Annika, we're using microorganisms to improve food safety. So specifically, that means traceability. So if you look at fresh produce or meat or dairy or what have you, the ability to have just sort of a next level of origin detection and that level of traceability, as well as fighting pathogens, mycotoxins, aflatoxins, just around the storage and transport of food safety, of food products. But what's really cool is that we couple that with actually our own insurance contracts that we sell to food producers and growers, and then we de-risk those insurance contracts with our own technology. So we've spent the last few years developing the actual tech, and now we're standing up through Lloyd's of London and with different insurance companies as partners, this whole insurance business where we can underwrite all these different food and agricultural risks using synthetic biology as a way to basically hedge ourselves. So it's kind of a new category creating type of enterprise. And so we've gone from, just here in this campus, we've gone from a 400 square foot lab and an idea to now building out a 30,000 square foot facility just in the next door building with the help of New York City and the folks here at Industry City. And so we're scaling our product, we're sort of expanding our insurance footprint, and that's all possible through the sort of infrastructure that's around New York City and the more investment dollars that are being poured in here as New York City as a SynBio hub. So,
All right, no slides from you?
no, let's skip them.
I'm going to skip through them then. That's what you would have seen if you learned more about. Uh-oh. Sorry.
All right, I'm back on the hook. Okay. So basically, like the space that we're creating, and it really addresses the bottlenecks for our own company, but also if you think of the bioeconomy in New York City, it's really about not just wet lab space, but sort of small batch fermentation, right? So we think that's a massive bottleneck for the industry. There are not many places you can go in New York itself in New York, or really up and down the East Coast, to be honest, that go from the bench to something between 5 and a couple hundred liters sort of runs, right? These guys are talking about 45,000 liters, but like, how do you get there? And that's kind of the gap that we're filling for ourselves, but that's also available, we're making that available to the broader bioeconomy. And so we think that was sort of the reason we got that support from the city, and we think that fills a massive problem. The other thing that we're doing, oh, sorry, Sam.
You can do my slides too. If you want.
Actually, it's hard to click through. But if you see those domes there, it's also really difficult to test out your product in sort of a contained space, especially within food and agriculture. So that's another critical element of the space that we're building here. The ability to test our antimicrobials, our antifungals, sort of in real time in sort of these greenhouses, if you want to consider them that, just in a controlled environment. Because we deal with EPA and other regulatory bodies, having all of that sort of infrastructure available here in Brooklyn is we think is really important just for ourselves, not just for ourselves, but again, for the whole bioeconomy there.
Thanks. I'm Sam, co-founder and CEO of Melon Frost. I do not have beautiful visual renderings of our space, unfortunately, but that's probably good because following up yours would be hard. I want to briefly change tacks and talk about, for a second, computer science in the 1970s, which is not necessarily the purpose of this meeting, but imagine you were a computer scientist in the 1970s tasked with creating a fully conversational computer program. You'd probably start by building language from the ground up, coming up with a list of letters in the alphabet, or rules for syntax or grammar, how those letters came together, phonetics, etc. Now, language is fairly complex, but I imagine given enough resources and 100 years, you might be able to build a fully conversational computer program, language model. Flash forward to now, 50 years later, we do have a fully conversational computer program. Many of you have probably talked to one in the last few months, ChatGPT, Bard, Pi, whatever your model of choice, chatbot of choice. However, ChatGPT wasn't built the way I just described. It has few, if any, rules programmed into it. Although it was possible to build a language model by engineering it from the ground up, it turned out it was immensely faster to simply build a system of constraints, feed it a lot of data, and let natural optimization processes run wild within it. Core thesis of my company, Melon Frost, is that the same will be true for biology. That the biggest falsehood at the heart of SynBio is that biology is an engineering discipline. Although, again, it is possible to build biology from the ground up, given enough time and resources. You can make a list of nucleotides and rules for how they come together, etc. We believe it will be immensely faster to build a system of constraints, feed it data, and let natural optimization processes run wild within that. Fortunately for us, we have the most powerful optimization process on the planet at our fingertips. It's been optimizing organisms reliably for billions of years. That's evolution. And more fortunately for us, we can borrow other optimization tools from computer science, like machine learning, to further harness evolution. So that's what we do. Melon Frost combines AI, machine learning, and evolutionary biology to build the world's first AI-powered evolution platform a tool that can rapidly optimize any strain or any organism for any purpose or trait. We do that by, we've built the world's most high throughput bioreactor system where we cultivate cells, measure traits. All that data is streamed in real time to our algorithms. They learn how organisms evolved, send instructions back down, make changes. The organisms evolve in new directions. New data streams back up. It's a feedback loop that gets more efficient and powerful with every crank of the mill. And in the process, we are building what is quickly becoming the world's largest evolutionary data set and producing industrial grade strains that are modified by nature, but directed by AI. And that's just the beginning. We are shaving millions of dollars and years off the bioproduct development timeline, hopefully making it faster for people like you guys to get from the lab to the shelves, building out biomanufacturing systems, and building the first foundational models of biology, because we believe the future of biology won't be engineered, it will be evolved. Thanks. So that's, yeah. It's not you?
This is not
That's
me.
not you?
Hi, everyone. I am Emily Bogan from Fork and Good. We are a cultivated meat company in Jersey City. Prior to that, we had lab space here in Brooklyn and also in Manhattan, but we just moved into our pilot facility, or our first meat factory, in Jersey City this November, and I think we'll talk a little bit more about how we chose to be here later. I just want to start by saying, why are we doing what we're doing? Agriculture is a really interesting space in the sense that it is a huge contributor to climate change, but it's also incredibly impacted by climate change. And so we think that animals are very inefficient protein conversion machines. And we are creating a better process to create meat, the same meat that many of us know and love. And so our first product is cultivated pork. To kind of paint the picture of the inefficiency of a pig, it takes 3 to 4 kilograms of corn or soy to create 1 kilogram of meat or mass in a pork. And so that's even higher if this is an antibiotic-free animal or a higher quality animal. So cows, many of you might know, are the most inefficient. They're 9 to 10 kilograms of feedstock in order to get to 1 kilogram. But we've chosen to focus on pork because it's really the reason that the demand for meat is expanding is largely driven by pigs. And so we believe that even though a cow as an individual animal might have it might contribute more to climate change, we think there are going to be many, many more pigs as our population reaches 10 billion people by 2050. And so ground pork is also the most widely consumed meat. We are highly, highly focused on our yield. Our process is to develop a high-yielding cell culture, and then we actually use genetic editing in order to make our cells grow faster and better and to immortalize them. We do not use stem cells. That's something that's a little bit different about us and then many other competitors in the space. We are not using FBS to grow as food for our cells, and we also have a patented, protected bioprocess, the way that we are kind of growing our meat. And yeah, thank you.
And so thank you all for those wonderful introductions to the work that you're doing in the spaces that you're operating in. And maybe just off the back of what Emily was talking about in terms of choosing New Jersey for their first pilot facility, you've heard from companies that are based in New York, in Brooklyn, in New Jersey. And so given that the title of this panel is Growing the Industry in New York City, or in New York, can you, we can go down the line, or maybe just a few of you, can you share your strategy or thoughts around, why New York? You could have built your companies anywhere. Maybe some of you are from New York and wanted to stay here, but what were some of the other reasons and impetuses for, why you strategically chose here.
Yeah, sure. Sorry about that. We actually got started in Boston originally in 2018, so we're maybe part of a small cluster of companies who chose actively to move out of what's been traditionally the biotech hub of the US, along with the Bay Area. And for us in the early days, a lot of the question around where we wanted to grow C16, came down to, where do we think we could recruit the right talent naturally, right? Where could we recruit the right talent? Where could we acquire the best resources to be able to, find the lab spaces or build the lab spaces that we need? But also, where could we, find the right resources to be able to build up the necessary infrastructure for pilot scale manufacturing, which is really hard to come by in most of the U.S. in general. There's a bit of the impetus for our move to New York was also just around competitiveness for lab space in Boston, which is really challenging for early stage startups. And we were kind of part of a wave of companies that wanted to see New York through as a growing life sciences ecosystem. And the lab space access was there, and it just sort of required that we bought into that opportunity. And obviously there's been no shortage of talented folks to be able to work with in the city. So that was part of the impetus for our move.
Emily?
Yeah, so there were a few things that really influenced why we're in New York. First of all, one of our co-founders already lived here. He's really a pioneer in this space. His name is Gabor Forgnach, and it was really important for him to be involved in the day-to-day because it influenced how quickly we were able to move. And then secondly, was kind of this relationship between, well, I'll kind of back up. We could have also gone to North Carolina. Another one of our founders was based in North Carolina. There was amazing lab space. We could have moved into kind of already outfitted space, but we're a food company. And the most number of Michelin restaurants in the United States are actually in New York City. There are other food companies who hold their headquarters here in New Jersey. And so we thought it would be easier to have a chef come to our lab, come play with our product if we were here, have investors come visit if we were here. And then secondly, or thirdly, we actually, just thinking about the talent aspect, New York is an exporter of STEM talent. We create all these wonderful scientists at Columbia, Rutgers, NYU, and Princeton, and then we send them to San Francisco and Boston. And then not even just thinking about STEM, but what are the other needs, kind of other functions from our product, our marketing. We felt like New York really stacked up on all of these places.
Yeah, that's a really good point. Like, both Ellen and I are both from New York, obviously, so it made a lot of sense. But I think it was two things. One, the industries in Boston and San Francisco are so well developed. I think there's just less room, and you can kind of have this big fish, small pond kind of tailwind here in New York City, which is tremendous. And then the second thing is there's an untapped resource of talent pool here because they're usually exported to the coasts. Here, like, being able to sort through that talent and sort of have like a first pick really is a tremendous advantage. So I think, to me, that's one of the biggest draws of New York City right now for your biotech company is you can have access to this talent pool that's like largely kind of a first look at all this great talent before the coasts, have an opportunity.
And Sam, I want to ask you a pointed question about kind of your most recent news, which is that you raised a new round of funding, which is congratulations, which at least I know for some individuals has been tough in this environment. And so can you give us any insights? You gave a really compelling narrative introduction to what Mellifrost does. So specifically for you, but then opening it up for others, are you finding it, or did you find it a challenge to talk to investors about the value of building a synthetic biology company or funding a synthetic biology company?
I have to say one thing about the last question too, because no one said it. It's also the greatest city on earth.
Fair. Maybe it's not said because we all know it.
But yeah, look, it's a tough time out there, and perhaps there is. It's a particularly tough time to be a capital-intensive business, which most of us are, because we have to build real things in the real world that have lab spaces, et cetera. So yes, it's a tough environment, but there are also still people out there, and I think the flip side of that is that there is a growing recognition of the urgency, in particular the climate urgency for biological solutions. That's
Yeah, and so it's also not just getting investors on board, but also consumers as well. And so maybe I can ask this question to Emily and David around, what are you seeing that consumers want and or need? Emily, I know you work in the food space, and David, I know for you, we'll have companies from food to fashion and now beauty. Kind of what was your strategy around focusing your first product for beauty? And then Emily, are you seeing an appetite from consumers around wanting cultivated pork versus cultivated beef versus seafood or things like that?
Yeah, for us, specifically when it comes to palm oil, palm is used in so many different kinds of products. It was a key question for us to be thinking about from day one about how we were going to get to market first, right? Food is the large goal. Something like 70% of palm oil is used as an ingredient or as a literal cooking oil for food. But there are, as you might imagine, higher regulatory approval sort of standards and processes that have to be sort of executed in order to get into the food space. The personal care space is a lot more flexible. There are a lot of customers who are already under a ton of pressure from end consumers, but also governments saying, there are restrictions now on the amount of ingredients you can use that are driven by deforestation. That's actually the case in the EU right now. And so the impetus is really there, and we made the active decision to launch in the personal care space because there's a lot of pressure to move forward there with palm alternatives already.
Yeah, so a couple of things. First, we really believe that the first place a lot of us are going to feel climate change is on our plate, and that access to affordable meat is going away. And so we're focusing on affordability, which is why we focus on ground pork versus, the cost to get to a more structured, a steak, for example, would be much more costly. And we didn't think a guilt-free solution for the 1% was a very interesting problem to solve. Secondly, we see ourselves as an ingredient company. We don't see ourselves as standing up a brand. So that means we'll be working with meat companies to fortify their supply chains as an ingredient, and just to kind of hedge against pork specifically. There is no vaccine for swine flu, and the supply chain is quite volatile. So, yeah.
And Anthony, I should also direct that similar question to you. I imagine, with the breast milk shortage, the formula shortage that happened last year, I'm sure you were seeing a huge need for the product that you were building. And so can you talk a little bit more about what you were seeing? And also, the fact that you are using precision fermentation, is that something that you think is either scaring consumers off or a phrase that more and more people are adopting?
Well, I think it's both, right? So you have, the opportunity is to provide these immunoeducational proteins. The only way to do it in a cost-effective manner is through precision fermentation. And then there's the inbound interest in these proteins from clients and consumers alike. I don't know if you know this, but there's actually a black market for breast milk. Mm-hmm. And the solution is not always infant formula, and although 70% of parents use infant formula at some time, so that has to be part of the solution. So what Helene is trying to do is bridge between breast is best and then into infant formula by introducing those ingredients. So there's a lot of inbound interest in that, but at the same time you have to manage the conversation with the consumer, and the best thing to do is really not to talk about precision fermentation. Just talk about the benefits of the ingredient and how it works for them and how it will be an improvement on the nutrition for their infant and then for other use cases as well, and let the ingredient tell its story and do what it does. Back in the day, we talked about precision fermentation to make vanillin, which is it's the main volatile compound in vanilla extract, but it's not vanilla extract, okay? But tried talking to the consumer about that. It got all confused, and All of a sudden, you have Haagen-Dazs pulling this material out of their ice cream because consumers didn't want to hear about precision fermentation ingredients. So you have to be careful how you manage that conversation.
Absolutely. And so for Vishal, I know something that we were chatting about earlier is your microbial tags for food safety. And I noticed that on your slide you said you're going to create a center for food safety and innovation. And so kind of what are your thoughts around what microbial tags could be used for outside of food safety?
Yeah, I think there's a whole other use case that we haven't really explored thoroughly yet, but it's about what is sustainably sourced. Specifically, regenerative agriculture practices have had sort of 40% less claims in crop insurance. But what do you know is like, how do you prove what's grown in what sort of using what practices? So we think there's a whole universe of different sort of non-food applications that are just in terms of, can be used in terms of verification and adherence and compliance to either better food safety practices or better sort of overall practices, whether was this using child labor or was this sustainably grown, to even like, is this authentic, right? Is this the products that you think, are the products you're buying what you think they are? And then outside of that, in terms of high value chemicals, they're really like an endless list of non-specifically food applications, but they're all around sort of authentication and then proving and provenance.
And so we have a few minutes left, and I do want to open it up in case anyone has questions, but maybe one last question I will have for the panel is, if we think 10 years from now, what do you think the conversation around the spaces that you're working in, what will they look like?
Well, I can say, because I already said, basically, I think we will be shifting more and more towards unbiased approaches and having less of an engineering framework and more of a computer science ML framework for biology.
And I think the biggest thing from a consumer perspective, I think this psychological barrier on like genetic engineering and all of these buzzy words, I think that will go away, right? I think you're seeing with ChatGPT now, it's like, it's just so ubiquitous and everyone's using it and they get it just kind of right off the bat that I think biology will have that moment at some point as well where you won't think about it. It'll just sort of be part of your everyday. Because I think right now there's just all this misinformation around genetic engineering and especially as it relates to food. But that'll go away just because you'll know it's making a better product in a better way. That's more, whether it's sustainable or can resist climate change or whatever. And I think that'll just be part of the sort of the fabric on how we operate.
Yeah, like basically our daily lexicon.
Yeah, that's right.
I was going to say real quick also, from a climate tech standpoint, I think the conversation around what we consume is going to shift from not only being how healthy is it for me, but how healthy is it for the planet.
It has to, yeah.
Quantification of CO2 emissions on every product, which is already starting, but I think that's going to be state of the art or standard.
Does anyone have any questions for our panelist?
Yes.
So, I know Isha and Qatar from Harvest pretty well because they shared our space for a while it's running a nonprofit. And I'm just wondering, it's my understanding that it's sort of a very long road to getting to a point where this was at a price point and we're starting to get to that point. How important was it that you had a nonprofit that was relying on donations mainly from animal lovers to kind of jumpstart some of the basic research that helped propel this to the forward?
I think it's incredibly important. And yes, it is such a long road to price parity. We only just came out of stealth in March because we started beating the feed conversion of a pig and started to feel really confident that we're there. And there are other things happening in the ecosystem like Nutreco and Merck building food grade facilities instead of needing to get farmer grade materials. I think it was essential to jumpstart. this industry at the start. I think GFI and the things that they are doing, particularly to influence policy, is very helpful to us. On the science side, it's moving so quickly that it's almost the things that are publicly available from the nonprofits or from GFI are almost out of date compared to what we're doing, but I think it's really important.
Suds?
You all talked about the great things about starting a company in New York City. Can you talk about what has been challenging and what should you, entrepreneurs starting a company, do here to mitigate that challenge?
For us, it's like building everything from scratch, like building out our lab space from scratch like twice now, 3 times actually. It's like been, I don't think you have those problems in Boston or San Francisco. It's so plug and play. So I think that's challenging. And then recruiting, even though all these people are here, it's like getting on the map, even though we're physically like down the street. It's just like, hey, no, New York's also like, there's a thing here. All of that has been, I'd say, the toughest parts. And once you overcome them, though, I think it's.
Any advice for the overcome part?
For the what?
For overcoming it.
You just got to keep plowing through it, I guess, and eventually it'll work.
And I would say one thing too is there is a community, and there has been a community. I think that we use words like community and ecosystem and networks and hubs, and I think that one of the things that has been a challenge, but I think is hopefully getting better, is the connectivity that we all have with each other and sharing resources and kind of trials and tribulations to say like, yes, I was there once where you were. Here's the person that I talked to, the resource that I used, the grant that I applied for. And I think it's incumbent on all of us to kind of show these pipelines, these pathways, so that other people can know both the highs and the lows of what it takes to build a biotech company in New York.
One of the thought challenges is access to certain resources and infrastructure needed for early stage biology and chemistry companies, in terms of very early stage startups might not have the money to put up and purchase a GCMS to do analytical chemistry testing. Where can we get access to those kinds of things in and around the city? They exist. There are lots of facilities for it, but finding those resources and connecting with them is really important.
Thank you all.
Thank you.
So now we have the second part of this panel.